Assalamu alaikum students. The new topic which I am taking in this video today is chapter 2 sound. Here we will see how sound is produced. Does the speed of sound vary in solids, liquids and gases? And at the end we will see which are the two types of waves. Sound is a form of energy. Sound travels in the form of waves. Do you know how is sound produced? Let us see few examples. In the first image, as you can see, when we hit the drum, we tend to vibrate the drum with the drumsticks. Due to vibrations, sound is produced. In the second image, when we play a guitar, we move the strings of the guitar to and fro, and those strings start vibrating. When they vibrate, they produce sound. In the third image, the object which is given in the image is called as tuning fork. It is used for practical purposes in physics. So what does this tuning fork do? We have to hold the handle of the tuning fork and bang it against a solid. As soon as you bang it, it starts vibrating. And you will see that as the tuning fork is vibrating, you can also hear sound. So, all these three examples indicate that vibrations create sound. Can sound travel through solids? Yes. In fact, sound can travel through solids, liquids, as well as gases too. But does the speed of sound vary in all these three mediums? Let's see this table. The particles in solid are very close to each other. So when we vibrate solids, they create the speed of sound is highest in solids. The particles vibrate at higher speed. In liquids, the particles are far away from each other. They are not too close. So in liquids, the speed of sound is less than solid, but it's more than gases. And in gases, the particles are very far away from each other. Distance between the particles is more. So here the speed of sound is the least. So sound waves travel at a higher speed in solids, while the speed of sound is least in gases. So your examples in the table, the medium is given and the speed in meter per second values are given. So gas, if we see, take an example of speed of sound in air, it is 350 meter per second. Speed of sound in water is 1500 meter per second, while speed in a solid, let's say a steel, If we bang a steel object, the speed of the sound will be higher and the speed of sound will be highest. That is 6,000 meter per second. That is why instruments are made up of solids, because they create more vibrations and the speed of sound is highest in solids. Now, do you think sound needs any medium? So, if I am speaking to y'all, I am the source and you are hearing my sound. So, y'all are the detectors. So, is there something, if we are in a classroom, is there something that is allowing my sound to reach y'all? Yes, sound needs a medium to travel. Medium can be air. Okay, so it can be air or it can be a solid, a liquid, or a gas. But sound needs medium to travel. It cannot travel in vacuum. Vacuum means in a region where there is no air. The small activity proves that sound needs a medium. Let's see what this activity is. You have to create a setup as it's shown in the image to the left, where you have a closed jar in airtight bell jar. The jar is bell shaped, that is why it's called as bell shaped jar, and that bell shaped jar is connected with a vacuum pump at below, and then there is a bell, electric bell, which is placed inside, and through a switch you can operate the electric bell. So what you have to do is you have to keep the electric bell in the airtight bell jar, and when you press the switch, you can hear the sound of the bell, because what is there in the bell jar? Even when we are inverting the bell jar, some air might have been escaped inside the bell jar, and when we are switching it on, so when we press the switch, we can hear the sound of the electric bell. But now let's see the second image. But now, using the vacuum pump, we have to remove all the air which was there in the airtight bell jar. Now there is no air inside the bell jar, and before removing the air through vacuum pump, we have to keep a alarm inside, a clock inside. So when the clock is outside, you can hear the clock. But when the clock rings after some time, if you fix a timer, and when you remove the air through the vacuum pump, you will find that the clock must be vibrating inside. It is vibrating, but you cannot hear any sound. Why is this so? Because that sound will reach to you only through a medium, and the medium is air, but we have removed the air through vacuum pump, so we couldn't hear any sound when we do the second step. So this small activity indicates or shows that sound needs a medium to travel. Now suppose you take a spring and you push it right and left through your hand. So what will happen? You are compressing a spring and then you are expanding the spring. So when you bring the spring close to each other, when you're compressing, that part is called as compression. And when you release the spring, it's called as rarefaction. So the waves which consist of compression and rarefaction are called as longitudinal waves. Sound waves are longitudinal waves because the direction of vibration of particle is parallel to the direction of wave. That means sound waves move forward with compression and rarefaction. When sound waves travel through air, the particles of the air starts vibrating and then they reach the receiver from the source. And they move forward by vibrating back and forth. So sound waves are longitudinal waves. So there are basically two types of waves, longitudinal waves. So sound waves are longitudinal waves. The properties of longitudinal waves are that the particles of medium vibrate parallel to the direction of the wave. They can propagate. Propagate means they can travel, they can move through solids, liquids and gases. And longitudinal waves consist of compression and rarefaction. Example of longitudinal wave is sound wave. Another type of wave is the transverse wave. Now suppose you take a rope and you move the rope up and down. So what are you doing when you are moving the rope up and down? You are creating waves. The rope will move like a wave as it is shown in this diagram. The wave, each wave, if you see the upper parts, the top part of a wave is called as crest and the lower part of a wave is called as trough. So in transverse waves, the particles of the medium vibrate at right angles to the direction of the wave. So now you're in this image, as you can see, the direction of travel of the wave is right hand side. And how are we moving? Suppose this is a rope. This wave will be produced when we move the rope up and down. That means up and down direction is perpendicular. It is at right angle to the direction of the wave. So it's transverse wave. Transverse waves can be propagated, means transverse waves can travel through solids and liquids, but not in gases. Transverse wave consists of crest and trough. So students, sound is produced when vibrations are created. Sound needs a medium to travel. Sound cannot travel through vacuum. Speed of sound is highest in solids and least in gases. And sound wave is a longitudinal wave where the particles of medium vibrate parallel to the direction of the wave, and it consists of compression and rarefaction. While light waves is the example of transverse waves where the particles of the medium vibrate at right angles to the direction of the wave. Transverse wave can propagate through solids and liquids but not through gas. And transverse wave consists of crest and trough. Thank you.